Okay, number 11 is easy because we're just going to throw it out. We didn't actually do number 11, so don't worry about it. Number 12. It may be a little hard to see the diagram on the video, but basically it says determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. So the only thing that's given is that LHO. So that angle right there is equal to NKP. So that's the only thing that we know, is that those two purple angles. This might work. Hold on. So, sorry about that, but I think you can see a little bit better now. So, either way, I have to think about, what does that prove? Does that prove that any of these lines are parallel? Well, if you think about it, we have a transversal cutting through two lines. This is line A and this is line B that look pretty parallel. You know, does that prove that it's parallel? Well, if you think about it, those are alternate exterior angles. And if alternate exterior angles are congruent, we learned, so there was a theorem that says if alternate exterior angles are congruent, then the lines are parallel. So that's what you want to say. You want to say that line A is parallel to B because alternate exterior angles are congruent. Okay, and that's the only pair of angles that ends up being congruent because of those two angles. All the other ones, there's not enough information. Okay, number 12. That's 13. So there's a lot of diagrams, so I'm going to leave these all up here. Alright, so here we go. This one's subtly hard just because you might not see, hey, that's 90 degrees. Alright, and then I have 37 degrees up here. So I know between those two I have 127 degrees. You know, 90 plus 37 gives me 127 degrees used up. Well, in the big triangle, if I make this F, FCD, I can use that to find X. Alright, so 180 minus the 127 that I already have gives me 53. So I know that X is equal to 53. Now that's pretty powerful because in the given it told me that AB is parallel to CD right there. Given that that's parallel and then FD is a transversal, I know that that's also 53. I know that that's a 90-degree angle. Alright, so it has to be 53. And what do I know about 53 and y minus 4? I know that they create this straight line. So 53 plus the y minus 4 equals 180. They form a straight line, so they make 180 degrees. So from there I can just kind of simplify, put the negative 4 and the 53 together. I get positive 49 equals 180. Subtract the 49, so I get y equals 131. So it just asks for y, it doesn't really ask for this angle, but 131 minus 4 is 127, and 127 plus 53 gives me the 180. So it looks like I did it right. So there's y, there's x. Alright, number 14. It says P and Q are parallel, so we know that these two are parallel. It says find angle 1. Alright, so there's a couple different ways we did this, and a lot of you ended up just extending your lines like that to make it look like kind of an X. Alright, and there's a couple different things I know. If this is 112, alright, 180 minus, so 180 minus 112 equals 68. So I know that those are vertical angles, so that's 112. It's going to be really hard to write in here, but I know that this is 68. Alright, because it's supplementary with the 120. Alright, I also know that since these are corresponding angles, that's 130, because that's a transversal cutting through there, and it's on the same side of the transversal, and they're both obtuse. So from there, I also know that this is 50. I don't know if you can see that, but 50 plus 130 gives me 180, and then inside the triangle, 50 plus the 68 equals 118. Alright, so (180) minus the 118 degrees that are already used up in there makes 62 degrees. So if that angle right there is 62 degrees, so is angle 1. So it ends up being 62 degrees, angle 1 is 62. Alright, let's keep going here. Identify the congruent triangles in the figure. So technically, you know, what a better question would be is identify the congruent triangles and why, or you know, what theorem says that they're congruent. And the theorem that tells them that they're congruent is angle, side, angle. Alright, but this is just more of a labeling thing. Triangle, there's not one way to do this, but if I start at M and I go to N, then O, that's congruent to triangle. So I started at M, went past side 1, and went to angle 2. So I have to start at J, went past side 1 to angle 2, so that's K, then L. Oops, sorry, I was off the screen there. So there you go. That is what they're looking for, a congruency statement. Alright, this says triangle N or MNP and OMN are congruent equilateral triangles. So you got to think about what's everything I know about equilateral triangles. Well, all equal sides, and then all angles are equal. So if you think about it, you have three angles, they're all equal, they have to be 60, 60, 60. So your angles of an equilateral triangle are 60, 60, 60. So given that, you know, it tells you that this angle right here is 3y plus 6, well, you know what it's equal to. It's equal to 60. So from there, it's just a matter of solving that equation to find y. So y equals 18. Okay, so you just have to know that about equilateral triangles. Their angles are 60. And then, since these are congruent triangles, I know that those two sides are equal. So I can take those two expressions and set them equal to each other. Once you do that, subtract x from both sides. Get 2x minus 12 equals 4. Add 12. 2x equals 16. X equals 8. Alright, so y equals 18, x equals 8. Okay, number 17. Find x if PQR is an isosceles triangle with the base of RQ. So an isosceles triangle has equal angles, two equal angles, but it also has two equal sides. And we know it's those two sides because it called RQ the base. Alright, so those are our two sides. 5x minus 3 equals 4x plus 20. Okay, and then just solve that. This goes pretty quick because I get 1x minus 3 equals 20. And then all I have to do is add 3 to both sides. 1x is just x. So x equals 23. Now it says find x. So we really don't have to plug it back in to find the actual side lengths. Okay, back to proofs. You thought that you would never see them again, but there will be a couple on the exam most likely. So here we go. Remember, you want to write down everything you know from the given. W is the midpoint of xy. Okay, so if W is the midpoint, I know that those 2 points, or those 2 segments, are equal, and it's the midpoint of VZ. So I know those 2 segments are equal. Last but not least, it says that WV, or XV, is equal to YZ. So there's a whole lot given there. It's just a matter of writing out kind of the obvious now. Okay, so the statements are all there. The first one's given. The second one, how do I know that XW is equal to YW? Well, isn't that the definition of midpoint? Don't midpoints cut something exactly in half or into 2 equal parts? So I know number 2 because the definition of a midpoint. Number 3 says W is the midpoint of, that's another given. Says it right there. So in this case, they wrote the givens in 2 different steps. Alright, number 4. How do I know that this segment, VW, is equal to ZW? Well, again, definition of midpoint. Okay? And then, that's another given. Number 5, the statement is right there. It's in the given. So a lot of this is kind of repeat. There's only really one fact. Definition of midpoint is used, given is used, and then why can we say that these are congruent? Well, remember we had the different ones. We had angle, side, angle, side, and side, side, side. Remember, angle, angle, angle does not work, and there's a couple other ones that don't work. But so number 6, since we have 3 sides that are congruent, this is congruent because side, side, side. Okay, 2 more proofs, and we're finished with 11 through 20. So, given AD is perpendicular to BC. Right off the bat, I know that that makes that a right angle. AD bisects angle A. So again, I know since it bisects angle A, I know that those 2 angles up top are equal. Alright, so we're going to kind of write out the obvious here. So the statement is that ADB and ADC are right angles. So it labels that both sides are right angles. Well, I know that by the definition of perpendicular. Since they're perpendicular, it forms a right angle, basically. ADB is equal to ADC. So they're basically saying the two right angles are equal. Well, you might say, well, duh, yeah, right. All right angles are congruent. All right, I use the word equal there instead of congruent. Now it says triangle B, or not triangle, angle BAD is congruent to CAD. So it's those two purple marks up there. How do I know that? Definition of angle bisector. Right. Definition of angle bisector says that an angle that's bisected is cut into two equal parts, basically. Alright, last one. So AD is equal to itself. We called that the reflexive property. Any segment is congruent to itself. And number 6. Now we can say that the two triangles are equal. How can we say that? Well, we have an angle, a side, and an angle that are congruent, and that's enough to say that the rest is congruent. So, by angle, side, angle, number 6. Then number 7, how do I know that AB is equal to AC? Well, there was something that we learned that basically said that, hey, the rest of the, if I make the statement that the two triangles are congruent, the rest of the parts of the triangle are congruent. The rest of the angles, the rest of the sides, and we called that CPCTC, which stands for congruent parts, or corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. So, alright, let's finish this up. Alright, the given is that AD bisects angle A. So I know that those two angles are equal from that. And it also says that AB is congruent to AC. Well, they're both radii. Alright, so that makes sense that they would be equal. And so the first one's given. It lists all the givens there. So angle ABC is congruent to ACB. Now, how do I know that that's true? Okay, so ABC is congruent. The second statement says that ABC is congruent to ACB. And the reason I know that is if I redraw that triangle, I know basically, it's cut down the middle, but the big triangle itself is isosceles. So since I have an isosceles triangle, triangle ABC is an isosceles triangle. Therefore, I know the two base angles are congruent. So you can say definition of isosceles triangle for number 2. Alright, number 3 says BAD is congruent to angle CAD. So I made those markings in the beginning, but how did I know that? It was because AD bisected. So I could say definition of angle bisector for number 3. Number 4, I think I have enough because I have angle side angle to prove congruency. So number 4 is, its reasoning is angle side angle. And then what we just did in number 19, since I said that they're congruent, the rest of them are congruent. So what do we use for that? We use CPCTC.